In this video, we're going to cover trigonometric identities, which is section 7.1 in the book. First thing I'd like to say is make sure to read the guidelines for proving trigonometric identities at the top of page 540. Proving trigonometric identities can get a little complicated, and there's not always a direct path for solving these kinds of problems. So the best way to get better at this is just by doing a lot of examples. But I am going to start with one example here. We'll actually do two examples, but we'll start with simplifying sine of t over 1 minus cosine of t minus cosecant of t. Your first option is we can try combining fractions after converting to sines and cosines. Usually, this idea of converting to sines and cosines is a good place to start, but it's not always the best approach. But I think it will be in this particular problem. So, let's try that out. First off, we'd like to notice that cosecant of t is equal to 1 over sine of t. So we can go from here. So let's rewrite this, and we get sine of t over 1 minus cosine of t minus 1 over sine of t. Now we can combine the fractions. How do we combine the fractions? Right, we're going to subtract the fractions here, so we need to have the same denominator. So I'm going to multiply by sine of t over sine of t here on the left. And we get sine squared of t all over sine of t times 1 minus cosine of t. And then we're going to subtract off the 1 over sine of t, but again, we need to have the same denominator, so we've got to multiply by 1 minus cosine of t on the right over here. So multiplying the numerator, we get 1 minus cosine of t, and in the denominator, we get sine of t times 1 minus cosine of t. All right, and from there, we will go ahead and combine the fractions. So we get sine squared of t minus 1 plus cosine of t. Right? We distributed the negative across, so this is a negative 1. That would be a positive cosine of t. And this is, of course, all over sine of t times 1 minus cosine of t. All right. Well, what is sine squared minus 1? Our Pythagorean identity, we have a Pythagorean identity here that, and I'll write that in this little margin. We have a Pythagorean identity that sine squared of t plus cosine squared of t is equal to 1. So, what is sine squared minus 1? That would be a negative cosine squared, right? If we move this over to the other side, we get sine squared minus 1 is equal to negative cosine squared. So, sine squared minus 1 becomes negative cosine squared of t. Then we have plus a cosine of t all over sine of t times 1 minus cosine of t. Okay, now we can factor out a cosine in the numerator. And we get 1 minus cosine of t. All right, I factored out a cosine out of the positive cosine here. We get 1. Factor out a cosine out of the negative cosine squared, and we get negative cosine. So this is, again, we're just going to rewrite the denominator. And hey, we have something that cancels. And we, in fact, get cosine of t over sine of t, which is cotangent of t. And we've simplified that to, well, as simple as that can get. All right. We're going to do another question. It's fairly similar. We're going to, so number 2 here says, prove the identity. And that identity is 1 plus tangent squared of u over 1 minus tangent squared of u is equal to 1 over cosine squared of u minus sine squared of u. When you do a prove the identity kind of question, you want to pick one side and make it equal the other side. So you usually pick the more complicated side. In this case, I would suggest that we start with 1 plus tangent squared over 1 minus tangent squared and simplify that to see if we can turn it into 1 over cosine squared minus sine squared. So that's what we're going to do. We're going to start with that left-hand side. And what can we do? Well, we have another Pythagorean identity here, which I'll write down. And that is that tangent squared of u plus 1 is equal to secant squared of u. So we're going to use that Pythagorean identity up here with the numerator. So 1 plus tangent squared is secant squared. So this becomes secant squared of u over 1 minus tangent squared of u. Okay, so notice that what we're trying to get to is in terms of cosines and sines. So I would suggest that we rewrite this in terms of cosines and sines at this point. So what is secant squared of u? Well, that is 1 over cosine squared of u. And what is tangent squared? Well, that is sine squared over cosine squared. So we get 1 minus tangent squared is 1 minus sine squared over cosine squared. And then, if we have a fraction here, we can just move this to the denominator. So this is the same as 1 over cosine squared of u times 1 minus sine squared of u over cosine squared of u. If we distribute the cosine here, the cosine squared, we get that this is equal to 1 over cosine squared times 1 is cosine squared. Cosine squared times negative sine squared over cosine squared is just a negative sine squared. And we are done. We've reached the side that we wanted, right? We've reached that right side. We reached that equation or expression that we had wanted. Expression. So, I would like to point out, before we end this video, those are the only 2 questions I wanted to do, but I'd like to point out that this is not always to see the exact approach. It's not always easy to see the exact approach here. I worked this out ahead of time and found out that this is the simplest way to do it. But the first time I worked out this problem, I actually tried something a little bit different, where I factored the 1 minus tangent squared into 1 minus tangent times 1 plus tangent. And then I tried to do all of this mess, and it really got more complicated. So I'm showing you this just to be clear that it's not obvious how to solve these problems. There's not just a direct path that's easy to see at the beginning of these problems. You really do have to work through these a lot and gain some expertise and experience and intuition on these types of problems. So if you start going down the wrong path at first, keep trying, keep going. Eventually you'll get there. Don't give up on the problems, is what I'm trying to say. Anyways, that concludes our video for section 7.1.